In this lesson, I'm going to help you understand the number base or the number system as a whole. You probably have come across numbers like this one, something like this, or even this, and might be causing confusion as per the system of numbers you're looking at. Observing all these numbers, you will notice that small numbers are written at the lower end of the large numbers. These small numbers are called subscript and they indicate the type of number system you're looking at. Another thing to note is these subscripts are numerically greater than the individual digits of the large numbers. Whereas this system of numbers may be confusing, I am very certain that numbers like these ones are never confusing to you. This is because most of our numerical activities are done using digits in this system, and as a result, we are well oriented on various operations involving these numbers. Comparing these numbers to the others, you will notice that there is no subscript attached to them, or is the subscript probably invisible? Well, we'll find out as we progress in this course. But know that, just like this system of numbers, there are other systems in which digits are counted or recorded. The systems in which digits are counted or recorded are collectively referred to as number base or number system. There are various types of number system, but I'm going to emphasize on the four most common systems, which are the binary system, the octal system, the denary or decimal system, and the hexadecimal system. Let's start from the binary system. The binary system is also known as base 2 numeral system. It makes use of only two digits, typically 0 and 1. These digits are each called a bit, and this system is mostly applicable in computer technology. Binary numbers are also used to label the power button or switch of some electronics. In writing binary numbers, the subscript of 2 is written just after the binary digits. This subscript is necessary for the readers to know the base or system in which the digits are written. It would be wrong to write a binary number this way or like this, because binary numbers cannot contain digits that are equal to or greater than the base, that is, 2. In other words, it is wrong to write binary numbers like this 2 example because this example contains 2, which is not permitted in the base 2 numeral system, reason being that it is equal to the base. Whereas, in this other example, 3 is not permitted because it is greater than the base. So, when writing binary numbers, ensure that all the digits are made up of 1 and 0 only. However, higher numbers like 2, 3, 4, and so on can be converted to binary numbers. For instance, 2 is written as 1, 0, 3 is written as 1, 1, whereas 4 is written as 1, 0, 0 in binary system. But don't forget to indicate the base. Let's look at the octal system. The octal system is also called base 8 numeral system. It makes use of 8 digits from 0 to 7. Just like the binary system, when writing octal numbers, a subscript of 8 is written just after the digits to indicate the base of the numbers. But unlike the binary system, higher digits like 2, 3, 4, 5, 6, and even 7 are permitted in the octal system, but digits which are equal to or greater than 8 cannot be found among octal numbers for the same reason as discussed in the binary system. For instance, it would be wrong to write octal numbers like this or something like this because this one contains 8, which is equal to the base, whereas this example contains 9, which is greater than the base. For such reasons, these two examples cannot be numbers in base 8. So, to correctly write base 8 numbers, All the digits need to be picked from 0 up to 7, either singly, repeatedly, or by combination of any of these digits. But don't forget to write the subscript of 8 after the numbers to indicate the base. However, 8 and 9 can be converted into octal numbers. 8 is written as 10, whereas 9 is written as 11 in base 8. Now, let's discuss some features of the Dinary system. The Dinary or decimal system is also known as base 10 numeral system. This system has a wide application over other systems. Natural numbers are in this system. I mean, all positive integers that we make use of in our daily numeral operations are in this base. The base 10 numeral system is so common in the sense that the digits on our calendar, financial entries, serial numbers, credit and debit card, and a whole lot of other instances of numbers are done in this base. The Dinary system is made up of 10 digits from 0 to 9, and these numbers can be written with or without a subscript of 10 to indicate the base. So, whenever you see numbers that have no subscript indicating the base, just like the numbers in the earlier part of this lesson, take such numbers to be in base 10 because it is the base of natural numbers. Let us now look at another common number base called the hexadecimal system. The hexadecimal system is also known as base 16 numeral system. It makes use of 16 characters comprising of digits and alphabets. The hexadecimal system uses 10 digits from 0 to 9. But since there are no more digits after 9, without the repetition of the already mentioned digits, that is 0 to 9, the hexadecimal system makes use of 6 letters, A to F, to represent numbers greater than 9. So, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. Hexadecimal numbers can be written using only digits or only alphabets. They can also be written by combination of digits and alphabet, but letters that comes after F, such as G, H, I, and others are not permitted in the base 16 numeral system. So, characters like this or something like this cannot be in base 16 because this contains G, whereas this instance contains K, and we know that G and K come after the letter F when arranged in alphabetical order. However, characters like this and this one can be in hexadecimal system because they do not contain letters that succeed F in the English alphabet. The subscript 16 is written afterwards to indicate that the characters are in base 16 numeral system. At this point, it will be important to know the following about number base generally. 1. All arithmetic operations can be carried out in all bases. Arithmetic operations include addition, subtraction, multiplication, and division. 2. The highest digit permitted in a base is always 1 less than the value of the base. For instance, the highest digit in base 2 is 1. The highest digit in base 8 is 7. The highest digit in base 10 is 9, whereas the highest character in base 16 is F, which represents 15, and 15 is one value less than 16, which is the base. Number 3. All numbers written without a base are assumed to be in base 10. 4. Numbers in a particular base can be converted to numbers in other bases. And lastly, there are several types of number systems, some of which are included in the following list.